Hello everyone, this is Ishita Man from Python Warriors. I'm a final year student of BTech Computer Science at the North Cap University, Gurugram. Today, we'll be learning exception handling in Python with the help of various examples. To start with, let's first understand what is an exception. So errors in Python can be of two types. The first one is syntax error and the second one are exceptions. So these are the two broad distinguishable categories of the types of errors in Python. Okay, so the first one, syntax error. I have a little piece of code here and we'll run this example to see what a syntax error is. So as the name suggests, syntax error is caused by wrong syntax in the code. It leads to termination of the program. Syntax error are also known as passing errors, and perhaps these are the most common kind of errors or complaints that you are getting while you're still learning Python. So let's run this code to see what a syntax error is. As you can see, I'm getting syntax error, invalid syntax. So the parser displays a little arrow pointing where the error was detected. You can see that there is a little arrow here and it is telling us that this is the place where the error was detected. So the error is caused by the token preceding the arrow. So this is the arrow and the token preceding the arrow is where the error was caused. So in our example, the error is detected at the if statement, since you can see a colon is missing after it. So there's supposed to be a colon after the if statement. The file name and the line number are also printed so that you know where to look. So this is the file and this is the line where the error occurred. Now if I add a colon here and then I run this, you'll see that there is no error. So this was an example of syntax error. It's a pretty basic example, but it gives you an idea. And like I said, since you're new at Python, you're probably experiencing a lot of syntax error already. Now, even if a statement is syntactically correct, it's not necessary that it'll always run, because it may cause an error when an attempt is made to execute it. So these errors which are detected during execution are called exceptions. I repeat, the errors detected during execution are called exceptions. And we will see how these differ from syntax errors. So exceptions are raised when the program is syntactically correct but the code resulted in an error, which changes the normal flow of the program. I have a few code snippets here and we'll see in these three examples that what kind of exceptions are raised and how do they differ from syntax error. Now if you look at these lines, this one, and this one, they seem to be syntactically correct. I mean, there's nothing wrong with them, but you will see what happens when we run them. So let's run these examples. This is the first one. This is the second example. And here, this is the third example. Right here. Okay. So you can see that even though these statements appear to be syntactically correct, I'm getting an error in each one of them. Okay. So the last line of the error message indicates what happened. You can see that here I'm getting zero division error. In the second example, I'm getting name error. And in the third example, I'm getting type error. So exceptions come in all different kind of types and the type is printed as part of the error message. So you can see that all these three exceptions and they are of different types, namely zero division error, name error and type error. The rest of the line provides details based on the type of exception and what caused it. So you can see the rest of the line here, it says division by 0. So I'm dividing 1 here by 0 and that's why I'm getting zero division error. So this is the exception caused here. In the second example, you can see that name error and it says that name spam is not defined. So this particular variable spam, it has no value associated with it and that's why I cannot calculate spam into 3. So in this case, this throws a name error. And in the third example, it says type error can only concatenate str, not int to str. So what I'm trying to do here is I'm doing plus operator stands for it also does addition and it's also used for concatenation. And I'm trying to concatenate an integer value to a string value and that's why I'm getting type error which says that you can only concatenate str and not int to str. Again, just as we looked in the example of syntax error, you can see that the preceding part of the error message, so all these lines, these right here and here and here. So the preceding part of the error message, it tells us where the exception occurred and the related context. So you can see that here it's at line 2, and again at line 2. And the other details and context of the exception are also printed. So I hope these examples have given you a pretty clear idea of what exceptions are and what are the two broad distinguishable categories, that is syntax error and exceptions, which are the two kind of errors in Python. If you go and check the official Python documentation, so here's a screenshot of the official Python documentation, and if you go and check the docs related to exception handling, you will see that all the kinds of exceptions and possible errors are listed here. So we have exception as the base class, and in the base class exception you can see that these are all the kinds of errors which your Python program can throw. So there's name error, memory error, lookup error, and among arithmetic errors you can have floating point error, overflow error, and zero division error. This is the one that we just got above. So the examples I showed you, they are a part of this whole hierarchy, and your program can throw all these kinds of error even though your code is syntactically correct. So you can go and check the Python docs and get a better idea of, and you can also see the details of each of these errors. So, okay. Now that we have understood what exceptions are, what errors are, it's time to learn how to handle those exceptions. I have a diagram here which explains pretty well how to handle exceptions. It may seem overwhelming at first, but don't worry, we'll go step by step and understand each of these keywords: try, except, else, finally, and also look at examples to understand how to use them. The first keyword we see here is try. So try, it's so as the name suggests, you are trying to run something, you're trying to execute a piece of code. So if you have any suspicious code that could possibly throw an exception, that could possibly stop the normal flow of your program, you can defend your program by placing the suspicious code in a try block. So the diagram says that this is the try block, and within the try block you write the code, run this code. So this is the main code or the program that you wish to execute. So all the suspicious code or whatever you're trying to execute, that goes in the try block, so that whenever my program could possibly throw an exception, I'm able to handle it. So again, I repeat, all the suspicious code, or by suspicious I mean that code which could possibly lead to any kind of errors in your program. So all that code goes in the try block. After the try block, we have an except block. So in the except block, we have that code which is ready to handle whatever exception is caused by your program. So here you write the suspicious code, and in the except block, you write some piece of code which handles the problem as elegantly as possible, and we do all the things possible to handle the exception in the except block. So again, try block, and you add all the suspicious code or the code which could possibly throw an exception, and you write all that code here. And after try block, we have except block, so that whenever an exception is caused, this piece of code right here in the except block, it will handle whatever error or problem is caused by your code. After the except block, we have else and finally. So these two are optional. And in the else block, what happens is that suppose you write some code and it throws an exception. So that exception is handled by the except block. But it's not necessary that every time your program will cause an error. We are doing this to make our code foolproof and to make sure that, okay, it is ready to handle all kind of errors. But if your code is perfectly fine and it doesn't raise any error, then if you want to do something, so that's what the else block is for. So no exceptions, then run this code. So again, I will repeat, the try block has all the code or suspicious code or whatever you are doing here. Now, if this thing right here, it causes an exception or an error, then that is handled by the except block. And after the except block, either this executes or this executes. So if there's no exception in my program, then I can write some code here in the else block, and this will execute the code here if there's no exception. And ultimately I have finally keyword. So finally is executed irrespective of whether the except and else block run or not. So it doesn't matter whether your program throws an error or not. If it throws an error, the except block will be executed. If there's no error, the else block will be executed. But irrespective of whether the except or else block is executed, the finally block is always run. So this piece of code is always run. Again, a quick overview of this diagram. We have 4 keywords: try, except, else, and finally. Whatever program you are writing and whatever piece of code there is, you write it in the try block. If this code in the try block causes an error, then that is dealt with by the except block. If there's no error, then the code in the else block is executed. And now whether the except block is executed or the else block is executed, the finally piece of code is always executed. So this was the summary and the basic idea of how exceptions are handled using these 4 keywords. And now we look at examples of how to handle exceptions. This was the syntax, and we'll be using the same syntax in all of our examples to give you a clear idea of how to handle exceptions in your code. Let's look at this example. Here's a simple syntax of the try, except, else, and finally blocks. So you can see I've defined a function here. The function's name is divide, and it takes 2 variables, namely x and y. So within the def function, I have within the divide function that I have defined, I have 4 keywords: try, except, else, and finally. So you can see this is what I explained here. Now in the try block, what I'm trying to do is that I'm dividing the variable x by the variable y, and I'm storing it in another variable result. So this is the piece of code which I want to run, and it goes in the try block. Now, as we saw above, there was 0 division error. I showed you this example where when you try to divide a number by 0, the program throws 0 division error. So to prevent that from happening, what we do is, here's my suspicious code. Now this is the line which may lead to an error in my program. And to deal with the suspicious piece of code, what I do is I write except 0 division error. Okay, so you can see that this was the suspicious code, and this could possibly lead to a 0 division error if my user, or if I pass the value of y variable as 0 to the divide function. And so I write except 0 division error. So in case there's a 0 division error, this piece of code will be executed. What I've written there is a simple print statement which shows that division by 0. You can write whatever that, okay, division by 0, not allowed. Let's just type that here, not allowed. Okay. Now, this was in case my try block throws an error. So if y was 0, then it would cause 0 division error, and this print statement would be executed. Now, what if there's no error? Then if you want to do something like, okay, the result is done. So suppose this works perfectly fine, and you want to show the result. Then I write that piece of code in the else block. So I written else, print result is result. So in case there's no issue with my code, and if the variable y has perfectly acceptable values, then this piece of code will be executed. And after try, except, else, I have finally. So I want that irrespective of what happens with my code, whether there's an exception or not, I always want to show something or do something. This is often useful to clear up variables and memory values after you're done writing a program. In my case, I've just written a simple print statement that finally clause always execute. So let's run this function. Okay, so this is executed. And then for the first example, I am passing the values 2 and 1 to the divide function. So what do you think will happen? Let's just try and guess. So you can clearly make out that x takes the value 2 and the variable y takes the value 1. We move to the try block. In the try block, result is equal to x by y, which is 2 by 1. Now 2 by 1 is a perfectly legal operation, and so there's no error thrown by it. As there's no error, this is not executed. This is not executed, then we move on to the else block. Else will print that result is, in our case, the result would be 2 by 1, which is 2.0. And then finally, clause is always executed, so it will print whatever you have written in the finally block. So let's run this to see. Okay, so that's exactly what happened. We can see that when you pass the values 2 and 1 to the divide function, this is a perfectly fine operation. There's no issue with these values, and so this is not executed. Except is not executed, my else piece of code is executed, and finally would always be executed. Now let's move on to a second example. I think by now I'm sure you have guessed it. So in this case, we are passing the second value, that is the value of variable y, as 0. So x takes the value 2 and y takes the value 0. Again, we move to the try block. Result is equal to x by y. So x by y would be 2 by 0. Now you know division by 0 is not defined, and in this case our program would throw an error. So the error would be 0 division error, but now we have already written a defense statement here for the suspicious code, which is except 0 division error. So in this case, what would happen is your piece of code, your program will print that division by 0 not allowed. So as a user, you are notified that you are passing the wrong values and y should be something else. Else will naturally not be executed because there was an exception, and else is executed only when there are no exceptions. And I have the finally clause. Again, whatever is there, if you write anything below this also, so whatever is there in the finally block, that piece of code will be executed. So let's run this. Okay, so you can see 2 by 0. This was, we got the exception, and therefore the except clause, the piece of code within the except clause is executed, and it's printing division by 0 not allowed. And then again we have the finally clause. So this is what I explained before, that in this case there was an error, and in this case there wasn't any error. But in both the cases, I always have the finally piece of code executing. Let's look at a third example now. Now you can see that in this case, I'm passing, instead of 2 integer values, I'm passing 2 string values. So string 2 and string 1. In my program, I've written result is equal to x by y. So what do you think will happen when my values x and y aren't integers? Naturally, it would throw an error because the operator division, this division operator, it doesn't apply on strings. So x and y cannot be strings if you want to divide those, and your program will throw an error. But do you think that here I have made any conditions, I've written any statements in the except block to handle that kind of error? I don't think so. So you will see that in this case, what we'll be getting. Let's run this. Okay, so like I said, it shows the error. We are getting a type error, and here's the description. Unsupported operand type or types for the division operator str and str. So here my x is str and my y is str. These are both of type string, and that's why the division operator is unsupported for these string values. But I just wrote an except statement to handle 0 division error. There is no except statement here which would handle type error. So in this case, my piece of code, my program is only capable of handling 0 division error. But if there's any possible error that could any other possible error like type error or name error, then my program will not be able to handle that. Now, to deal with such kind of situations, we'll understand what are multiple exceptions. So the diagram I showed you, it had 4 keywords: try, except, else, and finally. But it's not necessary that my program would throw only one kind of exception. Like we saw this hierarchy here, there could be all possible kind of errors that my program could cause. And so I can have more than one except statements with the try statement. So in this case, example, the error example, it showed type error. What I do is, I already had code to handle zero division error. Now I write another except statement, which what it does is, if there's a type error in my program, it will handle that error. So it will print that unsupported operand types for division operator. So now when I run this function, it's executed. And now I'll try the same example. I'll be passing 2 string values which are not legal for this division operator, and we'll see what the output is. So I run this and okay. Now what happens is, result is equal to x by y. X and y are both of string type with values string 2 and string 1. Except zero division error, this piece of code is not executed because there is no zero division error, except type error. Now yes, earlier this code was throwing a type error, you can see, and now I have added this another except clause to handle that error. So this except type error, what it's doing is, it's printing unsupported operand types. So you can see my output is printed unsupported operand types. And again, else block would not be executed. Why? Because else block is executed only when there aren't any exceptions in the code. And in this case, there was an exception. So else block is not executed. And again, finally, as the name suggests, finally is always. So whenever you are done with everything, finally will always happen. So finally, we have this print statement executing within the finally block. So this is my output right here. And this was an example to demonstrate multiple exceptions. You can go on and write n number of except clauses here. So I showed you two exceptions: except zero division error, except type error, and you can write any number of except clauses here. This example has 2 exceptions listed here, but like I said, in case of multiple exceptions, you can have n number of except statements after the try block. Another way of doing the same thing is, here what I have done is that I have written it in separate lines. So except zero division error is in one line, then except type error is in another line. And similarly, if you have more exceptions, then those will be one after another. But another way of doing the same thing is that whatever multiple exceptions are there, you write them in a single statement like this. So I've written except, and you use round brackets, zero division error, comma, type error, and also you can add other exceptions if there are. So you can keep writing them by adding more commas and writing the name of the exceptions. One important thing to note here is that the braces, these round brackets, this and this, these are necessary here for multiple exceptions. So in this case, we haven't used any brackets because these except statements are written in individual lines. But in case you want to club these errors into a single line, then you would have to use this round bracket. And this piece of code would work in the exactly same manner as this above one runs. So we can see that I run this code and then I pass the same values to the function. And when I run that, you can see that in this case, the output is, here I wrote specifically that if it's a type error, then I'm printing unsupported operand types. If it's a zero division error, then I'm printing division by zero. But here what I'm doing is that whatever exception is caused, so whether it's zero division error or type error, I'm printing error occurred and handled. So string 2 and string 1, when passed to this piece of code, it would result in a type error, and my type error, this except statement is catching this exception here, And because there's an exception, this print statement is executed, which says that error is handled, error occurred, and it's handled. So these are the two ways of using multiple except statements. And again, you can write as many except statements here, or you can write as many exception names here by just simply putting commas and writing those exception names in these round brackets. Now, in these examples, there's only one line of code that I'm trying to run, the actual operation which I'm trying to perform, which is x divided by y. And so it's very easy to figure out or to estimate what possible errors could this program throw up. But in case you have a really long program, then you cannot preemptively figure out that okay, these would be all the possible exceptions or errors that my program would be throwing. So in that case, it would not be feasible to write so many exceptions, so many except statements, or even if you're clubbing it into a single except statement, then also it won't be feasible to write all the exception names into a single line. So for that, what we can do is that we can use a single generic except statement. And unlike before, where I was writing the kind of error or exception that occurred, what I'm doing here is I'm simply writing except. So what this means is that you don't have to specify what kind of exception is occurring. You just write except clause, and whatever error is thrown by the program, it will be handled by the except statement. So I've written a very generic statement that something else went wrong. So it's useful for programs in which you cannot figure out beforehand that these would be the possible errors. And so to make sure that your program is capable of handling any kind of errors, what you can do is simply write one single except statement. And again, if I run this, so you can see that when I run this, I know that this is causing a zero division error because y is 0, but I have designed my program to handle all kinds of exceptions. So irrespective of what kind of error occurred, if there's any error at all in my code, this except clause would always be executed, and it will always be printing that something went wrong, something else went wrong. And again, finally is always executed. So this was all about exception handling. I would quickly go through the main points again, which were that a single try statement can have multiple except statements. So we saw that in the case of multiple exceptions, that a single try statement can have multiple except statements. And this is useful when the try block contains statements that may throw different types of exceptions. Then the second important thing is that you can have a generic except statement with the try block. So here I didn't mention what kind of exception or error would be occurring. I just had a generic except statement with the try block in the rest of the code. And another thing is that after the except clause or clauses, you can include an else statement. So what the else statement does it, that in case there's no exception in the code, then my piece of code in the else block is executed. And at last, the finally keyword. So you can use the finally block along with the try block, and the finally block is a place to put any code that must execute whether the try block raises an exception or not. So these are the main things and the basic ideas of exception handling that you should be aware about. I hope you enjoyed this tutorial on exception handling in Python. Good luck for your programming journey. Keep coding, and thank you very much for watching this tutorial.